Good morning, friends. Already we discussed about the Fraunhofer diffraction by a single slit. The arrangement of the Fraunhofer diffraction already we discussed. Now, today we are going to discuss about obtain the central maxima or the condition for central maxima and also the equation of the path difference. Which type of the interference or which type of the fringes obtained at particular point of a screen due to the Fraunhofer diffraction. Again, we discuss about the arrangement as shown in the figure. A source of monochromatic light S is placed at principal focus of a convex lens. Principal focus of a convex lens. Yes, the ray from source incident on a convex lens. So after the refraction, this rays becomes the parallel. This rays becomes the parallel. And incident on a slit. There is the slit LN. There is the slit LN, and midpoint is our M point. Now, according to the Huygens principle, all the points on the wavefront act as the independent secondary source and produce the secondary spherical waves. These spherical waves are propagated in the medium and superpose on each other and forms the interference. Due to the constructive and destructive interference, the bright and dark points obtained on the screen. Screen is placed at distance D from the slit LN. And also, the screen is at perpendicular bisector of a slit. There is the screen. There is the C point. The distance is D and also at perpendicular bisector of a slit. Now, due to the refraction and also the Huygens principle, what are the waves are produced by the slit, also the plane wavefront. With help of a second convex lens, so they are focused at the point C. And C is shown on the back. C is on the back, or the C is illuminated. So point C is known as the central maxima. Today we are going to discuss this thing. Now, which type of the fringes are obtained in Fraunhofer diffraction? For that purpose, here the another figure is there. There is the slit. There is the screen. Now, what are the wavefront produced by or the emanating from the convex lens are parallel, or the plane wavefront incident on plane waves. That is the slit. Incident on a slit. So as a result here, there is a C point. So here the fringes are obtained like this way. So there is the width of the central maxima. There is the width of central maxima. There is the width of the first order maxima. Width of first order maxima. On either side of the central maxima, the first order maxima is obtained. After that, on either side of central maxima, the second order maxima is obtained. Second order maxima is obtained. So these are the fringes obtained on the screen. That is the screen. So that is the fringes obtained in Fraunhofer diffraction by single slit. There is a figure B. And there is the arrangement, there is the figure A. Now we discuss this both figure. For that purpose, as shown in figure, a source of monochromatic light is placed on principal focus of convex lens. The waves coming out from a convex lens are parallel waves. So that plane wave front incident on a slit ln. Ln is our slit. According to the Huygens principle, all particles of a wavefront behave as a independent secondary source and produce a secondary spherical waves. Due to superpositioning of these waves, the interference is formed on the screen. Due to superpositioning of these waves, interference is formed. So that constructive and destructive interference take place and points on screen placed at principal focus of a second lens are obtained bright and dark. Bright and dark. The fringes obtained at different point of the screen are shown in figure B. Are shown in figure. So if this question is asked, now listen, in board exam, out of 3 questions, define or they explain the central maxima, first order minima, and first order maxima. Anyone is 100% asked, keep in mind that. So the answer of all the questions are same, but only what is the path difference are different. The concept of maxima and minima and central maxima are different. So only we describe the figure in central maxima, because the answer of the central maxima discussion is very short. Therefore, we have to also consider this arrangement of the figure in answer of the central maxima. And after the description of this arrangement, we discuss about the central maxima and obtain the path difference. Equation 4, path difference. Here we have to write down the description of figure. A monochromatic light, where the source of monochromatic light is placed on principal focus of a convex lens. There is lens L1. There is L2. So the light or the waves emerging out from the lens are plane waves. Therefore, the plane wave front incident on slit. Right? So after the refraction by the slit, so according to the Huygens principle, all the points on the wavefront or all the points of the slit behave as an independent secondary source. Behave as the independent secondary source. And produce a secondary spherical wave. These spherical waves are propagated in the medium. During their propagation, they are superposed on each other and interference pattern are formed. During this superpositioning of 2 waves, here the constructive and destructive interferences take place. As a result, on the screen, the different points are bright and dark are obtained. And what are the points obtained on the screen is shown in figure B. Now listen. Here the screen is placed at the principal focus of a second lens. This second lens is not shown in your textbook. But how these waves after the superpositioning focus at a particular point. So according to the position of the second convex lens, we can focus this superpositioning wave at a particular point on the screen. Clear this? Okay. So there is the arrangement of the Fraunhofer diffraction by the single slit. Okay, now central maxima. How we define the central maxima? That means the point C is shown the back. Here the figure is shown for the central maxima. So what are the waves are emanating from all the points of the slit at angle theta is equal to 0 with MC line. Right? Theta is equal to 0. So these waves are coincide or meet at point C. Therefore, the path difference of all the waves at point C is 0, because this upper ray travel a long distance in air but the less in length. And whatever the ray or the wave emanating from the point M travel less distance in air, long distance in glass. Therefore, all the waves meeting at point C at the same time, therefore the path difference will be 0. Therefore, the C is illuminated, but the C is shown the back. That is known as the central maxima. That is known as central maxima. Okay. Now for that central maxima, if width of a slit is small e, and the point C on the screen is placed at distance D, and perpendicular bisector of a slit, the point C on a screen. Screen is placed at distance d and perpendicular bisector of slit. If the angle at point M of a slit with MC line, there is a baseline, is theta is equal to 0. The path differs at point C. The path difference at point C between all waves emanating from the slit is 0. Thus, constructive interference is formed at C and it is illuminated. That means shown on the black. It is called central maxima or central maximum. It is called central maximum. Condition for central maxima is is theta is equal to 0 and path difference is also 0. So that is the condition or the discussion of the central maxima. How the central maxima is formed at point C. The path difference between the waves emanating from the slit is 0. That means what are the waves emanating in the direction parallel to the MC line? That means the theta is equal to 0. So these waves are focused by the second convex lens at point C. Having the path difference is 0, therefore that is known as the C point is shown the back and that is our central maximum. Clear this? So there is our discussion for central maxima. Now we are going to discuss about the equation for the path difference at any point on the screen. For that purpose here, the calculation of path difference, calculation for path difference. Now, here we consider the point P, this point P. So, what's happened here? The waves emanating from the slit makes an angle theta with the MC line. Makes the angle theta with the MC line. There is the MC line. Now, the waves emanating from the slit and suppose at point P are propagated in this direction. So it makes the angle theta with the MC line and focused at point P. So here, what's happened? For any point P on the screen, for any point P on the screen, if P makes an angle theta with MC line, therefore the path differs at point P is, now see in the figure, S which was the perpendicular from L1 in P, L1 in P. So that is the Q point. So that is the right angle triangle is formed. That is the LNQ. LNQ. So path difference in Q is equal to in P minus LP. In P minus LP equation 1. Consider triangle. Right angle triangle LQN. LQN. Now LN is already width of a slit. LN is equal to A. Right? And angle NLQ. NLQ. It's suppose theta. It's suppose theta. This angle is suppose theta. Therefore, sin theta is equal to sin opposite to the hypotenuse, opposite is NQ upon ln. Upon ln. NQ is our path difference, ln is equal to A. Therefore, path difference NQ is equal to NP minus LP is equal to A sin theta. So that is the equation of the path difference. Is the equation of path difference at any point P on the screen. So hence that is the answer of our question. We discussed about the central maximum and also we obtained the equation for the path difference. For the path difference, we consider any point P on the screen. Suppose here we consider P. Therefore, what are the waves are emanating in the direction, making an angle theta with the MC line are occurred at point P. Therefore, which step of the interference take place? For that purpose, the knowledge of the path difference is required. For that purpose, here we consider for any point P on the screen, if the P makes the angle theta with the MC line. So as a result, what's happened? The path difference at point P is NQ. NQ is equal to N to P minus L to P. Path traveled by the both wave emanating from L and also N. Now we obtain the right angle triangle, that is the LQN. In LQN, LN is our width of a slit A and angle NLQ is equal to theta. This angle is theta. Okay. Therefore, in this triangle, sin theta NQ upon ln, ln is equal to A. Therefore, NQ is equal to A sin theta, NQ is equal to this NP minus LP. So it's the equation of the path difference at any point P on the screen.